Math 3 students, Mrs. Robinson here to work practice benchmark chapter 3 with you. Let's start with the first one. Graph the function f of x equals 2x squared. I need to grab my writing tool. Hold on a second. Bring that over. Okay, so I'm going to graph the parent function f of x, or you can use y if you prefer, equals x squared. And then I'm going to notice I'm not shifting left or right, because if I shift my parent function, it looks something like this: x minus h squared plus k. And I would have some value a here that stretches or shrinks. I do have an a value here, so I am going to stretch. That's the value that I have here. I don't have an h or a k to shift me right or left and up and down. I just have an a value. So I'm going to stretch. Now, how much am I going to stretch? I'm going to make an xy table to tell me. If I start with 0 and I plug in 0 into this function, 0 squared is 0, 0 times 2 is 0. What happens when I plug in 1? If I plug in 1, 1 squared is 1, and then I'm going to multiply it by 2. So it's, instead of being 1, 1, I'm going to have 1, 2. It's going to go up higher quicker. Plug in 2. 2 squared is 4, and then 4 times 2 is 8. So there's a few points, and then I like to do negative points too, or you can use the axis of symmetry through the vertex. The vertex is 0, 0, so I'm just going to use all the points on the opposite side. So if I have 1, 2, I'm going to have negative 1, negative 2, and you can check that. If I plug, negative 1, positive 2. That was a brain fart. If I plug in negative 1 and I square it, and I multiply it by 2, I'm going to get positive 2. Plug in negative 2. Negative 2, and I square it, I'm going to get positive 4, and then multiply that by 2, and you're going to get 8. So you have enough to plot. You're going to have 0, 0, the point 1, 2, so over 1, up 2, the point 2, 8, over 2, up 8, and do the opposite side. You can use the axis of symmetry, which happens to be the y-axis, to plot those same points on the opposite side, but we actually figured them out. It was negative 1, 2, and then negative 2, 8. Negative 2, 8. And there is my parabola. It's stretched up from the parent function. It goes up quicker, higher, and that is an ugly drawing, but that's the basis of it. All right, let's go ahead on to number 2. Okay, graph this function. How is it a translation of the parent function? I know my parent function, f of x equals x squared, is just a parabola, something like this, at 0, 0. Now, I can see this in my parent function if I have y equals to a, that stretches or shrinks, times x minus h squared plus k. I know my h, k are my shifts. H comma k is actually my vertex when I'm in this vertex form. So I can see my vertex is not going to be 3, it's minus h. So it's always opposite. It's going to be negative 3, comma 4. I know that's my vertex, so I can see here I'm going to shift my parent graph to the left 3 and up 4. So I take my parent graph and I shift to the left 1, 2, 3, and I shift it up 4. 1, 2, 3, 4. That's going to be in my new vertex. Now looking at here, there's nothing written for my a value, so my a value is 1. When my a value is positive, my graph opens up. When my a value is negative, my graph opens down. Now my a value here is just 1, so it's positive. I know I'm going to open up. Let's just plot a few more points to make sure I open up at the right spots. So if I'm here at negative 3, let's go on either side. Let's go negative 2. Let's plug in that point. That's how I choose what I'm going to plug in, because I'm here. I want to know what happens on this side of my vertex. So on this side, if I plug in negative 2, I'm going to go negative 2 plus 3 and get 1. 1 squared is 1, and 1 plus 4 is 5. So I'm going to get negative 2, 5. And then because of my axis of symmetry, which I can kind of do as a dotted line here, axis of symmetry always goes through the vertex. Because of this axis of symmetry, if I hit this point here, I'm going to hit the equal point on the other side. I don't even have to plug it in. You could try -1 and see what happens, or maybe even 0. Plug in 0. So if I plug in 0, 0 plus 3 is 3. 3 squared is 9. 9 plus 4 is 13. So if I plug in 0, I'm going to be way up here at 13. That's 2 away from the axis of symmetry, or sorry, it's 3 away from the axis of symmetry. So I'm going to go 3 this way. 1, 2, 3. And it's going to be way up here too. So I'm going to have a parabola something like this. And that is what my graph should look like. Okay, on to the next one. All right, this one gives us everything we need to know. We don't even have an equation. We're just told, sketch the parabola with the vertex at 2, 1. So I'm going to go over 2, up 1. There's my vertex right there. A y-intercept of 5. So that means on my y-axis, I have this point 5. Now, if I know this is my vertex, I do have an imaginary right here axis of symmetry that goes right through my vertex. So if this is my vertex and I have this point, I have a matching point on exactly the other side right here. And I'm going to have the point 3 too. So I go over 3 and I go up 2. I also will have a matching point on the opposite side of my axis of symmetry. So here I have enough to graph. And it looks something like this. You can always go to Desmos.com and type in your equations and just double check your graphs. All right, next question. Identify the vertex and axis of symmetry of this function or this equation. Y equals x plus 3 squared minus 4. Now I know y equals to a times x minus h squared plus k is the shift of the parent function. HK is my vertex. So since HK is my vertex, I know my vertex is going to be -3, comma, -4. So it's always opposite the inside and then straight forward on the outside. -3, -4. Now my axis of symmetry goes through the x value of my vertex. If I drew this out, -3, -4, it would be here, and the axis of symmetry goes through the x value of my vertex. So this line is going to be x equals -3. There's my vertex, there's my axis of symmetry. All right, we want to identify the max or min value and the domain and range of the graph of this function. So remember, we have y equals to a times x minus h squared plus k. Well, we know a few things. HK is my vertex. My A value, if it is positive, I open up. If A is negative, I open down. So that A value is going to tell us a lot. If I'm positive and I open up, I'm going to have a minimum. This will be the lowest value. I'm not going to have a maximum because these will go on forever. Okay. If I have an A value that is negative, I open down, which means this point would be a maximum. All right. And then the domain and range, well, the Y value here at my vertex would be the lowest point. And the Y value here at my vertex for this would be my highest point. So that can help me figure out my domain and range. So looking at this graph, my A is positive. So I know I'm going to have a minimum value. My A equals to 2. My minimum value will be here at the vertex. So I know I'm going to have a min. So let's figure out what the vertex is. The vertex is HK, so my vertex is going to be vertex will equal -2, comma, -3. Now if I just want to sketch a graph so I have an idea of what I'm looking at, -2, -3. And I don't even have to graph an XY chart. I do know that because A is positive, I'm going to open up. So I'm just going to sketch. I don't know where this is going, but I am going to open up. So this vertex would be my minimum value. What's that minimum value? Identify the max or the minimum. The minimum value will be on the Y. How low can I go? So the minimum value would be -3. All right, and then the domain and range. Well, domain is all the values that the x could possibly be. Well, x can be any value. It can go this way forever or this way forever. So x can be all real numbers, all the values, okay? The range is different. The lowest value, the range is your y values, and the lowest value you could be here is right here at -3. It has to do with my minimum, all right? So for the range, all my y values need to be greater than or equal to -3. You're not going to get any y values below -3. So that would be my range. And that's how you do that one. Okay, on this one, we're going to use the vertex form to write the equation of this parabola. Let's just write down vertex form, not standard form, vertex form. Y equals some value a times x minus h. We're going to square that and add k. Now hk is easy, that's my vertex. I can see that right away. My vertex is -2, 2. There's my vertex. So I know my vertex is -2, 2. I'm going to plug that in here. It's going to look like this. Y equals some value a times x minus the x value of my vertex. So minus -2 makes a +2 squared, plus my k value is 2. So now I've written this, but I still need to figure out this. Does it stretch or shrink? I don't know. Well, I can figure that out by picking any value on this graph and plugging it in for x and y. That will allow me to find a. So pick a value right where it crosses on an exact point, right here. So that point would be -1, 5. Let's pick the point. So on this graph is the point -1, 5. This parabola goes through -1, 5. So what I can do is plug in 5 for y. I'm looking for a. A is still what I need to find to finish my graph. I got to find that. So I'm going to go 5 equals a times, and then my x value I'm going to plug in -1 plus 2, square it, and plus 2. Now I have everything I need to solve for a. So let's go ahead and simplify this. -1 plus 2 is 1. 1 squared is 1. So this is going to be a times 1, which is just a. This all turns to 1 after I simplify it. And 1 times a is just a. So now I'm going to get 5 equals a plus 2. Subtract 2 from both sides, and you're going to get 3 is a. We figured out a. Now I have everything I need to write this parabola. Y equals 3 times x plus 2 squared plus 2. So my graph shifts to the left 2, up 2, and it stretches by a factor of 3. So if it hadn't stretched, it would have been a fatter one, a little bit fatter. Okay, on to the next. Okay, what's the vertex form of y equals x squared minus 2x plus 8? So this is nice. I can graph out a vertex form by going -b over 2a is the x value of my vertex, and then plugging in to find the y value of my vertex. I can, but let's put it in vertex form. Y equals a times x minus h squared plus k. And then I can just see my vertex. This takes a little bit of work. In order to get it in this form, I need to have a perfect square here. It doesn't look to me like I have a perfect square. To figure it out, I take my middle term, I divide it by 2, and I square it. If I take -2 and divide it by 2, I'm going to get 1. 1 squared is 1. So what would make this part a perfect square is if I added 1. But I have 8. So what I'm going to do is I'm going to complete the square and make this be a perfect square. I don't have an a value here that I have to factor out first. If I did, I would first want to factor that out of these two terms. I don't, so I'm just going to write x squared minus 2x, and I'm going to put my 8 over here just to hold it over there. I want a value here that will make this be a perfect square, so I can write it like this. To figure that out, I take my middle term, I divide it by 2, so I'm going to go -2 divided by 2, and then I'm going to square that. Well, -2 divided by 2 is -1. -1 squared is 1. So if I add 1 here, I have to keep my equation. I can't just add 1. I could add 1 to this side to keep it balanced, or I could add 1 and subtract 1 from the same side. Okay, so that's like adding nothing, 0. Now this term is a perfect square. It's going to be x minus, if that's a minus, this is a minus. And then you just divide that by 2. It's x minus 1 squared. Okay, and you can FOIL this out and make sure you get x squared minus 2x plus 1. But it's always this divided by 2. That's what goes here. Okay, and then we're going to add 8 minus 1, which is 7. So now I have y equals to x minus 1 squared plus 7. And now I'm in vertex form, and my vertex is 1, comma, 7. If you did the negative b over 2a thing in standard form to get your vertex, negative b would be negative, and then my b value is negative 2, so it would be a double negative, over 2 times my a value, which is 1. This would be positive 2 divided by 2, which would be 1, and I still get the same value. And then I would come over and plug this in for x to get my y value, which would give me out 7. So I would get 1, 7 also, even if I did the negative b over 2a for your vertex, comma, the y value for that. Okay, number 8, we're going to rewrite this one in vertex form. We're going to name the vertex and the y-intercept. The y-intercept is really easy to find. To get a y-intercept, you plug in 0 for x. So your y-intercept is always c. When you're in standard form, y equals to ax squared plus bx plus c. A, b, and c, your y-intercept is always c, because if I plug in 0 for x, this becomes 0, and this becomes 0. It's just 34. So bam, found my y-intercept already. It is 34. It's way easy to see in standard form, way easier than in vertex form. Let's go ahead and go to vertex form. Let's say I didn't want to put it in vertex form. I can get the vertex, remember, by going negative b over 2a and then plugging in this value into x to get my y value. That also gives me my vertex when I'm in standard form. Let's go ahead and complete the square to put it in vertex form. We're going to go y equals to x squared minus 12x, and then my perfect square is going to be half of this, which would be 6, and then I square 6 and I get 36. This almost was the perfect square, not quite. I needed 2 more here. I'm going to go ahead and move this over here, and I'm going to make this be a perfect square so that I can be in my vertex form, y equals a times x minus h squared plus something over here. This needs to be my perfect square trinomial, and so I have to make this be by taking my middle term, negative 12, and dividing it by 2. And then I'm going to square it, and I'm going to add it here, and then to keep my balance, I'm going to subtract it over here. So if I take this and divide it by 2, I get negative 6. Negative 6 squared is positive 36. So that's what I need to add to make a perfect square here. I have to subtract it because I can't just add stuff unless I do it to both sides. If I add it, I got to subtract it. So now I've kept a balance. Now this is my perfect square. Remember, it's always x. If this is minus, this is minus. And it's always half of this, which would be 6, or the square root of that, which is 6. And there's my perfect square, x minus 6 squared plus 34 minus 36 is 2. Remember over here how I said you need 2 more to make a perfect square? That's really what you needed, 2 more. So y equals, there is my vertex form. And my vertex is 6, comma, negative 2. Oh, excuse me, positive 2. Shame on me. It's opposite this, and this is straightforward. It's 6, comma, positive 2. And there's my vertex. There, that's better. Okay, there's my vertex and my y-intercept. That guy's easier to find in standard form. Plug in 0, 0. My y-intercept is 34. And you're done. Okay, here asks us what's the max or the min value of this and what's the range. All right, number 9 asks what's the max or the minimum value and what's the range? Well, it's in standard form. We could put it in vertex form to see what the vertex is so we can figure out the maximum or the minimum, or we could just use our negative b over 2a and then plug that in to find our y value. So this is in standard form. Y equals to ax squared plus bx plus c. I'm putting my, hold on, I got my hand on. Okay, my hand was on the tablet and it wasn't letting me write. Okay, so our A value here is going to be 2. That's our A value. Our B value is next to the X, so our B value is 28, and our C value is -8. Now the beauty of the C value, that is your y-intercept, remember. Now I need to figure out the range or the max or the min. My A value always tells me if I open up or down. Now A is positive, so I am going to open up. So what I'm going to have here is a minimum value. So I'm looking for a minimum value. Now let's go ahead and figure out what that is by figuring out what the vertex is. So I'm going to go -b, which will be -28, over 2 times my A value, which is 2. So this will be -28 divided by 2 times 2 is 4, and that's going to give me -7. So -7 will be the X value of my vertex. Now to figure out the Y value of my vertex, I take -7 and I plug it back into my equation. So my Y value of the vertex will be Y equals to 2 times -7 squared plus 28 times -7, that's an 8, minus 8. Just do the math on this and you're going to get Y is going to be equal to, let's see, -106. And that will be the Y value of your vertex. Now, if I were to graph this, I would have to go ahead and step my y-axis, but on my x-axis, I'm going to go over 1, 2, 3, 4, 5, 6, 7, and I'm going to go down 106, like way down here. But I know I'm positive and I do open up, okay? So I know I'm going to open up this way, right? So my minimum value will be way down here. The lowest I can go will be my Y value, -106. That will be my minimum. What's the range? The range, remember, is what can your Y values be? Your Y values have to be greater than or equal to -106. So both of these, this number answers both of these questions. All right, on to the next one. Let's do some factoring here. I like to factor by unfoiling. Now you get this by foiling, basically multiplying 2 binomials to get a trinomial. I like to factor by unfoiling, and I know there's lots of ways. You can do the box, you can do the X where you add these up, you can do your chart where these terms need to add up to be these terms. All of those are valid ways to factor. I like to unfoil. So I know when I FOIL, I do my first terms, and then I do my outer terms, and then my inner terms, and then my last terms. So I know here and here are my first terms. My first terms have to multiply to make this. So I know that goes here and here. My last terms have to multiply to make this. And I need to make sure my inner term and my outer term add up together to make 14x, the middle term. Okay, so my inner and my outer. So I have to figure out what multiplies to give 48, but adds to give me 14. And if you prefer to do the same thing with the x, you can. All right, so I need to figure out the factors of 48. I know 48 is divisible by 8, so do 8 and 6 give me 14? They're both positive. Well, 8 plus 6 is 14, so ding, 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 let's do those two, 8 and 6. Now I check my inner terms, 6 times x is 6x, and I check my outer terms, 8 times x is 8x. Do they add to be my middle term? They do. So I know I factored it, x plus 6 times x plus 8, and there I have it. All right, on to the next one. This one, let's go ahead and factor, hold on. All right, let's factor number 11. I'm looking at this one and there's no value here again, so awesome. So I'm just gonna unfoil, and that's my favorite method. I know x goes here and here, and the factors of 8 go here and here. I gotta figure out the factors of 8 though that add to be -6. So I'm gonna come over and be like, what multiplies to give me 8 but adds to give me -6? So I know 8 would be 8 times 1. That's not gonna add up. Or I can do 2 times 4. Well, 2 times 4 could possibly give me -6. This is positive, but that's negative. So let's go negative times the negative. That gives me a positive, and if I add those, that gives me -6. So there's my factors. -2 would go here, -4 would go here. Check it when you FOIL. FOIL is the first terms, ding. Then you do the outer terms and the inner terms. And then the last terms, ding. Let's check the outer and the inner terms. So my inner terms are -2x. My outer terms are -4x. Do they add up to give me -6x? They do. And now I know I factored it correctly. Okay, let's go on to number 12. Number 12 has a negative in front. That is going to throw off my factoring. So what I'm going to do first is I'm going to factor out that -1 out of everything. If I factor out that -1, it's going to leave me with x squared, then positive x, and -42. That's just easier to work with, and then I can multiply by the negative at the end. So let's go ahead and factor this. This term goes here and here. And the factors of -42 need to add up to be +1. So what would that be? The factors of -42 that add up to be +1. Well, I know 6 times 7, that's looking promising to give me 1. It's a negative, so one of these needs to be negative. It's going to be the 6, because when I add these together, I'm going to get +1. So I'm going to get -6, +7. Let's go ahead and check the inner term and outer term and make sure it does add up to be 1 here. So I got -6x, and then the outer terms, 7x. Do those add together to give me 1x? They do. -6x plus 7x is 1x. And here I still have this -1. It's -1 times this, so I'm going to write -1 here times all of this. Now, it would be okay if you had not factored this out. You could multiply this back in. If I multiplied that back in, it would look like -x plus 6 times x plus 7. That would be a negative, that would be a positive. Or if you multiplied this by that term, that would be a negative and a negative. Either way, so this is fine and this is fine. Let's look at number 13. This one, it's 2 terms, so I don't have a trinomial. So let's look at how I could pull out the greatest common factor. That would be my first step. Now, the greatest common factor would be the greatest term that each of these have in common. So I can see they both have an x in common, so I'm going to pull that out. Okay, the biggest term. And then what divides evenly into both of these? Well, 8 divides evenly into this, and 8 divides evenly into this. So I can pull an 8 out of both of those. I can divide an 8 out. If I divide 8x out of 16x squared, well, if I divide 8 out of that, I'm going to be left with 2. If I divide an x out of x squared, I'm left with an x. And if I divide 8x by 8x, I just get 1. And that to me looks most factored. There's nothing else I can pull out and you're finished. All right, let's go on to number 14. Now number 14, I do have a term here and it is negative. So first off, anytime I have a negative, I hate working with those. Let's just pull it out a -1 first. And before I even pull out a -1, let's see if there's a greatest common factor before I even start multiplying or factoring my trinomial. Is there a greatest common factor in each of these terms? Because if there is, my factoring will be so much easier. They each have a 4 that divides evenly into them. So I'm going to say yes. So instead of pulling out a -1, let's pull out a -4. That'll make my whole problem so much easier. So factor out the greatest common factor first. Remember to do that. If I only have a 1 in front, like these ones, I don't have a greatest common factor to factor out just yet, unless there's a variable. But here I have a constant, so I can factor out a -4. So I'm going to be left with x squared. Divide -4 out of this. This is going to turn this negative because it's positive. And that's going to leave me with -2x. Divide -4 out of this, and it's going to leave me with -8, not +8. All right, now that looks much easier to factor. If I want to factor this, I'm going to do my FOIL method. I have to bring down this -4 because it's still part of this. Don't forget your -4. A lot of students do that. Don't forget it. All right, I know this term goes here and here. And the factors of this term go here and here, but I got to check those. What are the factors of -8 that could add up to be -2? Well, I know 8 is 2 times 4. That could possibly give me -2 depending on how it works. Well, let's do the 4 as the negative and the 2 as the positive. One's negative, one's positive. That gives me -8. And when I add them, I do get -2. So I'm going to go +2 minus 4. And then go ahead and check your inner terms. This gives me 2x. My outer terms gives me -4x. And I want to make sure they add together to give me my middle term, which is -2x, and they do. Now my final solution is the -4 times x plus 2 times x minus 4. So many times students forget this when they factor it out. Don't forget that part. Okay, on to the next one. This one has a 3 in front. Let's see if I can divide it out by factoring out my greatest common factor. All right, does 3 divide into 26 or 35? 3 doesn't divide into 26, and it doesn't divide into 35, so I can't. So I'm going to have to do, there's a couple methods that work here. I like to do the guess and check where I do this. I still just use my FOIL method and I guess and check. I say, well, this term has to go here and here. So what are the choices or the factors of 3x squared? I know it's an x and x still. I have to figure out the factors of 3. Well, the factors of 3 are easy. They're just 3 and 1. If there's multiple factors, I would come over here and write all the factors of 3, 1 and 3. If it was a bigger number and there's multiple factors, I'd write them all. But luckily, there's only one choice. It's 3 and 1 or 1 and 3, depending on which way you want to write them. So only one choice there. But then I have to figure out the factors of 35. Now, the factors of 35 are not going to add up to be 26 because of this number. So I have to figure out the factors of 35, and then I have to guess and check to make sure the inner and the outer terms add up to be 26x. This guy's going to throw me off. So this is called the guess and check method. Instead of breaking it all into 4 and then doing that whole blob, I just keep doing this method and I just guess and check. I put the factors here, all the possible ones. Luckily, there's only one. Now I got to do the possible factors of here. So let's go. The possible factors of 35 are 35 and 1, 5 and 7. Any other factors? I think that's it. Nice. I don't have that many tries. I want this to be 26. I want to have my inner term and my outer term to be 26. So if I did 35 and 1, let's say I did that. 35 here and 1 here. When I multiply this out, I'm going to get 35x. And when I multiply this out, I'm going to get 3x. And 35x and 3x is not going to add up to be 26x. So it's not going to be that one. Let's go ahead and remember, I want it to be 26x. It's not going to be 35 and 1. Let's try 5 and 7. I could have gone 35 and 1, or I could have gone 1 and 35. That's not going to work for sure. So let's try 5 and 7. Now, do I do 5 here and 7 here, or do I do 7 here and 5 here? I'm going to guess and check. Let's do 5 and 7 and see what happens. 5 times 1x is 5x. 7 times 3x is 21x. 5x's plus 21x's is 26x's. So it was 5 and 7. Now, had I done 7 and 5, this would have given me 7x, and this would have given me 15x. And it wouldn't quite give me 26x. So I wouldn't be correct if I'd done it the other way. I'd have to erase and try again. So by guessing and checking, I figured out what it is. It's 3x plus 5, 1x plus 7. Here it is. Now, if you'd like to do it the way the book did it without guessing and checking, so remember, with the guess and check, you just use the FOIL. What are the factors of this go in the first term? And the factors of this go in the last terms. So you write the factors of this and you make your guess. And you write the factors of this over here and you make your guess. And then you check your middle terms and make sure they add up to be your middle terms. It's just a guess and check. Now, if you don't want to have a more surefire method, this is how you would do it. You would multiply your first term by your last term. So you're going to go 35 times 3, and you're going to get 105. And then I'm going to figure out the factors of 105 that add up to be 26. This is why I don't like this method, because 105 is such a huge number, it's hard to figure out the factors for it. So I know this is divisible by 5 because it ends in 5, so I'm going to divide it by 5, and 105 divided by 5, this is going to give me 5 and 21 as factors. Luckily, there's only those two factors. We'll do 5 and 21 added to be 26, yes. So what I do is I multiply this first term times the last term. That will be here, and those two numbers, the factors of that number have to be the middle number. Then what I do is I take this middle number and I've broken it into these two. So I rewrite this as, let me give myself a little space here. I rewrite this middle term and I'm going to write this as 3x squared. The middle term I'm going to break apart and I'm going to make it plus 5x plus 21x. So I broke apart my middle term. And now I write my last term. So when you have a number here, you're not simply done by figuring out these factors. Oh no, there's more steps. You got to break apart that middle term. And then what you have to do is you have to factor by grouping. Group these two together and group these two together. Pull out the greatest common factor of these two, and it looks like it's just an x. And that leaves me with 3x, and then if I pull an x out of here, I'm left with 5. Pull out the greatest common factor of these two. Well, let's see, 7 goes into 21, so I'm going to pull out a 7, and 7 goes into 35. So I'm going to pull out a 7 here. And if I pull out a 7, I'm left with 3x. And if I pull out a 7 out of here, I'm left with 5. If these two don't add up to be the same, then factoring by grouping didn't work. So what I can do now is I have x times 3x plus 5 plus 7 times 3x plus 5. I can now factor out 3x plus 5 because that is a common factor in both this term and this term. When I factor that out, I'm left with x plus 7. Okay, so 3x plus 5 and x plus 7 is how I got it this way. And here 3x plus 5 plus x plus 7 is how I got it guess and check method. I prefer the guess and check method because sometimes this can be big and I can have too many choices here. But if you want to do where you multiply the first times the last, write down its factors to figure out what adds up to be the middle term. Then break up that middle term into two factors. You factor by grouping, you pull out the greatest common factor, and you end up with the same solution. So guess and check or this method. Guess and check works for everything. It works when there's not a number there, and it works when there is a number there. When there is a, well, there's always a number there, it's 1. But when there is a constant there, just make sure you find the factors of that, and it goes here and here. And then you find the factors of this, and it goes here and here. And you just got to check to make sure your inner and outer terms add up to be your middle term. And if it doesn't, you try again. All right, let's go ahead and look at this one. This one's a special one. You should recognize these, the difference of two perfect squares. If that guy's a perfect square and that guy's a perfect square and that's a minus sign, you have the difference of perfect squares. And we did this in Algebra 1, or sorry, in Math 1. So if I have the difference of perfect squares, it's this term minus this perfect square, which is 8, and then this term plus this perfect square, which is 8. And when you have a minus in the plus, the middle terms fall out, and that's why you only have two terms. And there you're done. All right, on to 17. Let's go ahead and solve this. Solve each quadratic equation using whichever method you think is best. So I'm looking at this. What do I think is best? Do I want to solve it by graphing? Remember, if you solve by graphing, you're looking to find out where your graph touches the x-axis. Where does it touch the x-axis? Okay, those are the zeros of the function. It is where your y is 0. Okay, where does it touch the x-axis? That's what I want to know. I could solve by completing the square. I could solve with the quadratic formula. So what's the best method here? I could solve by factoring. Now I'm going to go ahead and add 28 to this side and see if I could solve by factoring. X squared plus 11x plus 28 equals to 0. Does this factor? If it does, I can use the zero product property and find out where this is 0 or where my y is 0. Okay, so I'm going to go ahead and do this term here and here. X goes here and here. And then I'm going to remember the factors of 28. What are they? They have to add to be 11. Since I don't have a term here, they do add to be 11. I love it when I don't have a term now. So the factors of 28, let's see, 28 is divisible by 4, so 7 and 4. Do 7 plus 4 make 11? They do. Ooh, we picked a good one. 7 and 4. So 7 and 4 work. It's positive, positive. So I am going to do this by factoring. X plus 7 times x plus 4 equals 0. So what makes this, either this had to be 0 or this had to be 0 for this answer to be 0. It's called the zero product property because I'm making a product of two numbers by multiplying. So either this was 0. Well, what makes this 0? If x were negative 7. That's a negative. Negative 7 plus 7 is 0. What would make this 0 if x were negative 4? Negative 4 plus 4 is 0, and then 0 times anything is 0. So x had to be negative 7 or negative 4. Now you could check this by graphing using Desmos. I'm going to pull up Desmos real quick, or you could graph it by hand, but let's pull up Desmos. Okay, I pulled up Desmos.com, and I'm going to graph x squared plus 11x equals negative 28. I'm actually going to pull it to the other side and go y equals x squared plus, I'm graphing the related equation, sorry, I meant to do plus, 11x, and then I'm going to move 28 to the other side and make it positive 28. Okay, and when I graph that, you can see on my graph, my solutions would be where y is equal to 0 because I was actually graphing, I was pulling this to the other side and setting it equal to 0. So here's the related equation, and we want to know the zeros when y is 0. It would be here, you can see it, negative 7, 0, and negative 4, 0, which is the same solutions we just got. So I've checked it by graphing. Good job. All right, on to the next one. I can go ahead and use Desmos to graph this, or whichever method I think is best. Now, factoring is going to be not my favorite here because this is a 3, and there's not a great, 3 doesn't divide into 25, so I can't pull a 3 out. This would be hard to factor. I have to do it with that thing and then do the whole guess and check or do the break it into 4 thing. I don't like that. These are much easier to factor. So I could complete the square. That is never my first choice. My first choice for this one would be either to use Desmos and see if it hits a perfect point or use quadratic formula. Remember, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we're going to say that's what x equals to. X equals to this. So I have this in standard form. My ax plus bx plus c. My a is 3. My b is 25. My c is 42. Make sure you have the values right. And then just go ahead and say x is going to be negative b, so negative 25, plus or minus the square root of b squared. Well, 25 squared is 625. Minus 4 times a times c. 4 times a, which is 3, times c, which is 42. And that is all, the whole thing is over 2 times your a value, which is 3. Now just do the math on this and simplify it out. Okay, 4 times 3 times 42, this is all going to be 504, all right? So I'm going to go 625 minus 504. If I do 625 minus 504, I'm going to get 121. So let's rewrite this. This will be negative 25 plus or minus the square root of 121. Oops, that's a 2. Let me try that again. 121 all over 2 times 3, which is 6. Now, is 121 a perfect square? It is. It's 11. Yay. So I'm going to go negative 25 plus or minus 11 over 6. So I have two problems here. I have negative 25 plus 11 over 6 and negative 25 minus 11 over 6. So do negative 25 plus 11 over 6 and then negative 25 minus 11 over 6. Two problems here, two solutions is what I meant to say, and that 11 is so ugly. Let me try that again. There we go. All right, so negative 25 plus 11 over 6 is going to be negative 14 over 6. Okay, and this does reduce. this will be -7/3. And you can give me a decimal form if you want. And then here, -25 minus 11 is going to give me -36. And this will be -36/6. And 6 goes into 36 and leaves you with -6. So my solutions would be -7/3 and -6. And that fraction would be really hard to solve by graphing because you wouldn't see an exact value. So this quadratic formula is the best method to get an exact value. All right, there are your solutions for your x. That is where y is equal to 0 on a graph for the related equation. These are your zeros, okay, or your solutions where the graph touches the x-axis. All right, let's go ahead and solve this one. I would solve this one by first dividing both sides by 3. Okay, and I'm going to get x squared equals 21 divided by 3 is 7. And then to solve for x, I just take the square root of both sides. Now remember, when you square root of both sides, you get the plus or minus solution. So careful. When I square root both sides, I get plus or minus the square root of 7. Now the square root of 7 is not a perfect square, so I'm just going to leave it like that. Plus or minus the square root of 7. Two solutions there. Okay. Whenever you're solving for x and it's squared, you should have two solutions, right? Okay, let's go on to number 20. How are we going to solve this one? This one looks like maybe it might factor. If it factors, it's probably the easiest method. Let's see if I can factor this real quick. The first term goes here and here. The factors of the last term go here and here. So what are the factors? There's no term here, so I don't have to do that word multiplication. What are the factors of 14? 1 and 14, 2 and 7. That's a 4. 2 and 7. So which one of these groupings would give me 10? Well, 1 and 14 don't give me 10 anyway. 2 and 7 also don't give me 10. Oh man, this is not going to factor pretty. So what I'm going to do, since it doesn't factor pretty, these don't add up to be 10. It's going to be some weird numbers. I could complete the square, or I could use quadratic formula. I always pick quadratic formula over completing the square. I just think it's more straightforward. So I'm going to go x equals to -b plus or minus square root of b squared minus 4ac all over 2a. And then let's go ahead and do that. So my a value is 1, my b value is 10, my c value is 14. So I'm going to go -b, hold on. So we're going to plug in -10 for b, plus or minus the square root of b squared, which is 100. B squared would be 10 squared, which is 100, minus 4 times a, which is 1, times our c value. Oh, I just wrote equals. I meant to write c equals. Times our c value is 14. Now, and we're going to do that all over 2 times our a value, which is 1. So let's do some simplifying. Let's do 14 times 4 first. And that's, let's see, 14 times 4, and that's 56. So we're going to go 100 minus 56. And go ahead and simplify under the square root first. 100 minus 56 is 44, so this will look like this. -10 plus or minus the square root of 44 all over 1 times 2 is 2. And that looks like a 9, but it's a 4. 44. All right, 44 is not a perfect square. It's 4 times 11, and we could pull out the square root of 4, which would be 2, and make that be 2 square root of 11, and that's how we could simplify this. So it would look like this: -10 plus or minus the square root, or 2 square root of 11 all over 2. Now that still isn't most simplified because 2 divides into 10 and 2 also divides into 2, and this is all one term. So as long as it divides evenly into both terms, you can go ahead and simplify that even more. 2 divides into 10, and that's going to leave us with -5. And then 2 divides into 2, and that's all one term. So this is going to be plus or minus I'm going to divide this out, and it leaves me with 1, which I don't need to write. I'll just write square root of 11. So I have two values here, -5 plus square root of 11 and -5 minus square root of 11. And you can write it like this, -5 plus or minus the square root of 11, or you could write it as -5 plus square root of 11, and then comma -5 minus the square root of 11. And that doesn't look like an 11 there, but it is. All right, and that's how you would do number 20. You that put this in decimal form, just be aware on the online test, they will probably have it in root form. Okay, looking at number 21, how do I want to solve this? Do I want to graph it? Do I want to try to factor it? Do I want to complete the square? I'm going to go, since there's a term here, and I can't divide it out, which if I could, I would divide it out of both sides. I'm going to go quadratic formula again on this. -b plus or minus the square root of b squared minus 4ac all over 2a. And just go ahead and solve it that way. My a value is -2, my b value is -5, and my c value is +5. And that is a 2. It doesn't look like a 2. And let me try that again and make that a little prettier. Okay, hold on. A value is -2. All right, let's go ahead and plug it in. -b, so we're going to go, excuse me, negative, and then my b value is negative, so it's a double negative, which is going to make a positive. Plus or minus the square root of b squared will be as -5, and when I square -5, I get +25, minus 4 times my a value, which is -2, times my c value, which is 5. And we're going to put that all over 2 times my a value, which is -2. Now let's do our simplifying. This becomes positive, and I'm going to go 25 minus 4 times -2 times 5. Well, 5 times -4 would be -20, and -20 times -2 would be +40. So all of this becomes +40. And then I'm going to go 25 plus 40. So let's rewrite this as 5 plus or minus the square root of 40, 50, 65, all over 2 times -2, which is -4. Now we just need to see if I can pull anything out of that root with the square root of 65. All right, 65 factors into 5 times 13. Neither of those are perfect squares, so I'm really finished here. And I have, all I have is 5 plus or minus the square root of 65 over -4. Now you can simplify this and write it as 5 plus square root of 65 over 4, excuse me, -4, and then 5 minus the square root of 65 over -4. You could even simplify this more and divide 4 into both terms, and it would look like this. -5/4, and then if I divide into this term, it would be negative square root of 65 over 4. That would be the first term. And the second term would be -5/4. And then a negative and a negative makes a positive. So plus square root of 65 over 4. And that could be the terms. Or you could do the square root on a calculator and find some decimal form and round it. But the test that I've created will be in square root form, so be aware. All right, let's look at number 22. Okay, don't be afraid of this word problem. It looks scarier than it is, but the most important thing to remember is when you're working with real life parabolas and equations, you're not going to have nice clean numbers. It's going to be stuff like this. So don't be afraid of it. Let's look and see what we have. A bridge with under arch support is needed to span a dry riverbed near San Diego. So that might look something like this. There's an arch, a parabola type arch, and there's a bridge. Okay. And then the road continues on, and the bridge might look something like this. If you've seen bridges like this. It's spanning a dry riverbed, and here's the parabola, the arch. The underneath side of the bridge is an arch that can be modeled with 3 equivalent functions. So they've actually given us an equation form, but here's the first function. And to me, if I look at this, this is in standard form. Y equals something times x squared, ax squared. My a value is this decimal, but it's just ax squared plus something times x. And then my c value is just 0, which means my y-intercept is 0, which means if I were to draw an axis here, let's draw an axis. If I were to draw an axis here, like something like this, okay, this would be at 0, okay? The y-intercept would be at 0. That's all that means. And then let's go ahead. That's the first form. Now look at the second form they give us. These are 3 equivalent equations. They've already factored them out for us. Look at this form. This form, to me, looks like it is a factored form of this. So what they've done is they've factored out the common factor. My dog is banging his head against the wall trying to get out. Hold on. Okay, so this is a factored form of this. So they've taken this and already factored out the greatest common factor. There was an x in each term and they factored this out. And then they factored out this term or this number, 0.00495. They factored that out. So when they divide that out of this term, it just leaves me with x. And when they divide that out of this terms, it leaves me with 1250.51. So this factored form is fabulous when I'm solving by the zero product property. Okay, so that's already factored for us. Fabulous. And then this last form right here is in vertex form. So if you look, it's y equals to a times x minus h squared plus k. So I'm given all the forms. I've got my factored form, I've got my vertex form, and my standard form. And all of these tell me great things, okay? So we have these 3 forms where x and y are in feet. How high above the riverbed will the bridge be to the top of the arch? How long will the section of bridge above the arch be? How long? So basically they're asking this. How high above the riverbed will the bridge be? So I want to know the max height. That's all it's asking. What's the max height? How do I find the max height? Well, I look at the vertex. The x value of the vertex tells me how far I go over. The y value gives me my max height. I'm in vertex form right here. So my vertex is negative, because this is negative and this is negative, it's going to be positive 625.293. That's the x value of my vertex. My y value of the vertex is 193.516. Now my a value is negative, so that means it opens down, which they already told me. So this will be a max value. How high above the riverbed will the bridge be to the top of the arch? What's the max value of the vertex? That's all it's saying. Well, that value is right here, the y value of my vertex. So how high will it be? It will be 193.516. They said it's in feet. Feet. Okay, that's the height. So there I answered my first question. My second question is, how long will the section of bridge above the arch be? So how long, basically, is the bridge from end to end? So from this point to this point, how long is that? Well, I know I'm at 0. This is where I touch the x-axis at 0. So I want to know the zeros of my function. Where does it touch again? Here at 0. That will give me the length of x. Okay, so that is my x. If this is my y, that's my x. I just need to know from here to here. I need to know the x value when I touch the x-axis. So when y is 0, what is this x point right here? That will tell me the length of my bridge. So I can do that a few ways. I could graph this and just try to guesstimate this point. Or look, they've already given me the factored form. Set y equal to 0 and solve for your zeros. This you already know is 0. Figure out what this is, and if you know this x value, you have your length. So use your factored form. If y is 0, which is what I want, y is 0 here, y is 0 here, I'm going to go negative 0.000495 x, and that's multiplied by x minus 1250.51. Solve this. Okay, zero product property. If this times this is 0, then this has to be 0 or this has to be 0. What makes this 0? This isn't subtracted at all. If I just plug in 0 here for x, everything becomes 0. so x is 0. Or this value, what makes this 0? If x were 1250.51. That would make this 0, because that minus that would give me 0. So my x values are 0, and this value here would be 12, well, I lost my pen, 1250.51. So what's the length? The length would be 1250.51 feet. So this is the height. This is the length of the bridge. And you're done. Okay, that last problem looked harder than it was, right? That wasn't that hard. Whenever they're asking from end to end, they just want to know the x-axis. They want to know the x value. You just need factored form. Plug in 0 for y, and you can figure out your x value. Okay, so just think about what it is. Draw a picture. Always draw a picture. When they said, how long was the bridge above the arch right here, you just want to know from end to end. So really you're looking for the zeros. So we're just asking you the same thing again and again. Just try to figure out what they're asking by drawing a picture. And once again on this one, let's do that. The function y equals negative 16t plus 46. These are real numbers. This models the height y in feet of a water balloon t seconds after it's dropped from the top of a tall building. How long will it take the water balloon to hit the ground? Round your answers to the nearest hundredth of a second. Well, draw a picture. If you're at a tall building and you drop a water balloon off the ground in an arch shape, okay, and I'm going to go ahead and draw an axis too. If my initial point is here and I'm dropping it on the ground, okay, and I know my x-axis will be in t seconds, that's what I have for my x, and then my y is the height. My y is feet. So this is seconds, and this is feet. This is height. Okay, so I'm on a tall building. Drawing this picture helps me see so much. So this basically is like the top of my vertex, and it's coming down and it's hitting the ground. So I want to know how long will it take the water balloon to hit the ground. So if I start at 0, I want to know when it's here. That's how long it will take. So at 0 seconds, I haven't started yet, I'm all the way up here. And I throw it in an arch, it's half a parabola. I throw it in an arch and it hits here. And when it hits here, that tells me how long it will take. So I just need to know the x value here. These are my zeros of my parabola. Well, this won't be a 0 because the parabola will come around this way and give me a negative value, which I don't care about. I just need to know this 0 of my parabola. How do I find the zeros of my parabola? I want to know when y is 0. Okay, when y is 0, that gives me this value here. So, excuse me, I come up and I just say, well, where's my zeros? When y is 0, I have negative 16t squared plus 486. Now I could go ahead and plug this in on Desmos, and I could scroll over, or on a graphing calculator if you have one of those, okay? I could scroll over and see what point this is for my x, and that would tell me how long. Or I could solve this. Subtract 486 from both sides. That eliminates that, and you get negative 486 equals negative 16t squared. I'm solving for t, so I'm dividing by negative 16 on both sides. Yay, got rid of that negative. Good. Let's go negative 486 divided by negative 16, and I'm going to get approximately 30.375. That will equal t squared. Okay, and I'm going to erase this. And then to solve for t, I will square root both sides. And when you square root, you get the plus or minus solution. So when I square root that, if I square root 30.375, I get an approximation. And it said round to the nearest hundredth, so I'm going to round to 2 decimals, 5.51. That is a plus or minus, and that is what t equals to. So the time would be here at 5.51, and it would be back here at negative 5.51, because technically my parabola, you know, comes down like this if it were to make a perfect parabola, right? It would have this negative value. Now I don't care about that negative value because I started in the middle at my vertex, okay? So I don't care about that negative value. I only care about the positive value. That's how long it will take me right here. From here to here, it takes 5.51, and it's in seconds. So I'm going to put S for seconds, and I'm finished. So just look at what you're trying to do. Draw a picture. I need this point here. What is that? That's a 0 of my function. I can either graph it or plug in 0 for y and solve. Same stuff. Okay, these last two are systems of equations. Here I've got a quadratic. I can tell because it's an x squared is the leading term of my polynomial. Here I have a linear function. I can tell because x is the largest term. Here I have two quadratics. So I can graph this and see what this looks like. I'm going to pull up Desmos real quick. Okay. I went ahead and pulled up Desmos and I typed in both those equations, and here they are. The red's the parabola, the blue is the line, and you can see here, if I look here, I'm at the point -2, 3, and I'm over here at the point -4, 1. So graphing it on Desmos is super easy to figure out the solution, or if you have a graphing calculator, you do the same thing. If I want to do this algebraically, I can use substitution here. I'm going to plug in x plus 5 for y. And I'm going to go x plus 5 equals x squared plus 7x plus 13. Okay, now we're going to solve. So I'm going to subtract 5 from both sides, or excuse me, subtract x. I don't know why I said 5. And then I'm going to get 5 equals x squared. And then 7x minus x is 6x plus 13. Subtract the 5 to the other side so you can set it equal to 0 and factor. 0 equals x squared, that should be plus 6x, and then plus 8. Now that I have this, I can use zero product property. I'm going to go ahead and factor, and this term goes here and here, and this term factors here and here, so I have to figure out the factors of 8. That would add up to be 6. So 8 is 2 times 4, positive, positive, and that does add up to be 6. So I'm going to go positive 2, positive 4. Yay, that's nice and clean. And I'm going to come up with what makes this 0 when x is -2. What makes this 0 when x is -4. Now those aren't my solutions. I only have the x values of my solutions. I need the points where these two intersect. Okay, so I only have the x value of my point. Don't give me this as a solution. Plug this back into either of these equations and figure out the y value of your point. So I'm going to plug in -2. I'm going to plug it into the second equation, way easier to figure out the y value. So for -2, it's going to look like this. Y equals -2 plus 5. So y is going to equal to 3. So when x is -2, y is 3. And the point would be -2, 3. Now do it for this one. Plug in -4 here. And I'm going to get y equals -4 plus 5. And then -4 plus 5 is 1. So my y value will be 1. So that point will be -4, 1. And these are the 2 points where these two intersect. Let's double check again on Desmos. And I'm going to just, now it's writing all over this place. Hold on. Okay, so I can see right here is -2, 3, and right here is -4, 1, just what we did. All right, let's go on to the last problem. And we have two quadratics. So I'm going to go ahead and type those in on Desmos and see what those look like. Okay, I typed these in on Desmos, and you can see I've typed in those exact equations. Now, upon first inspection, it looks like it hits at 3 points. But let's zoom in a bit. And you can see this point right here actually doesn't touch. So it's touching right here at -530. And then it's also touching right here at -3, -10. Okay. When you zoom out, it looked like it might be touching there, but it's not. It's just these 2 points right here. And you zoom in, this does cross over just slightly over the other one. When you zoom in, you can see, okay, the blue does cross just slightly over the red, almost lines up for a second. And it hits at those 2 points. All right, so let's go ahead and work this algebraically. All right, algebraically, I'm going to go ahead and use substitution. These are both equal to y, so I'm going to go and say, all right, let's plug this in for y here. And it's going to look like this. Negative x squared plus 2x plus 5 equals x squared plus 18x plus 35. Now I'm going to do some solving here to try to make this work out. Let's get everything to one side. So we're going to add x squared to this side, and that's going to give me 2x squared. I'm going to do it all at once. Subtract 2x to this side, and then subtract 5 to this side. So I did it all at once, and then this all becomes 0. And then let's go ahead and add these together. You get 1x squared plus another x squared is 2x squared. And then 18x minus 2x will be 16x. And then 35 minus 5 is going to be plus 30. Now I can go ahead and try to solve this. Now if I go ahead and try and factor, I can see the 2 has a greatest common factor. 2 is a greatest common factor. So I can go ahead and pull out a 2 before I do my factoring. If I pull out a 2, I'm left with x squared plus 8x plus 15. That is equal to 0. Now the nice thing about doing that, I can then go ahead and divide both sides by 2 and just get rid of it. 0 divided by 2 is just 0. 0 can divide by anything, but you just can't divide anything by 0. 0 can be on the numerator. That's okay. It just cannot be on the denominator. Okay, so now I've got this. Nice. Zero product property. Let's factor. Hopefully this is a nice, easy factor. This goes here and here. We need to figure out the product of 15. That adds up to be 8. So 15 is going to be 3 times 5, or 1 and 15. 3 times 5 does give you 8. So plus 3, that's a positive positive. So plus 3 plus 5. And you can check your inner terms and your outer terms. 3x and 5x does give you 8x. So we've gone ahead and factored it. Woohoo! Okay, so let's go ahead and look at this. This times this is 0. What makes this 0? Well, if x were negative 3, because negative 3 plus 3 makes this 0. What makes this 0? Well, if x were negative 5. So when x is negative 3 and x is negative 5, this is 0. If I set this equal to y, basically I'm looking at the x-intercepts here at negative 3 and 5, because that's where my y is 0. Let's go ahead and that's when I'm solving a quadratic. But let's go ahead and figure out the y values. When I plug in negative 3 to this, let's see what happens. I can plug it into either equation. Maybe the bottom one looks a little easier. So let's go y equals to negative, and then I'm plugging in a negative 3. We got a double negative going on there, and I'm squaring it, plus 2 times negative 3 plus 5. And just go ahead and do the math here. Negative 3 squared is 9, and then I multiply it by a negative, so I get negative 9. And then 2 times negative 3 gives me negative 6 plus 5. So if I go 9 and 6, I'm going to get 15, negative 15 plus 5. It's going to give me negative 10. So my y equals negative 10 when x is negative 3. Negative 10, negative 3, and write that as an ordered pair. This is where these two intersect. I'm not looking where one intersects the y-axis. This is where these two intersect. Now go ahead and plug this in here, and I'm going to get y equals to negative and then negative 5 squared. It's a double negative there. Plus 2 times negative 5 plus 5. So negative 5 squared is 25. 25 times the negative is negative 25. Then this gives me negative 10 plus 5. Negative 25, negative 10 is negative 35. Plus 5 gives me negative 30. So this y gives me negative 30 when x is 5. Y will be negative 30. And that ordered pair, I'm going to squish it down here, would be negative 5, comma, negative 30. And there are the 2 points where these two parabolas intersect. Double check it on our Desmos and just see if we pull down. Remember, what was this point right here? If we go ahead and look at it, this point was, there he goes, negative 310, which was our point here. And then this one down here was negative 5, negative 30. And we did it. We solved it algebraically. Okay, guys, that's how you do this practice benchmark. Let me know if you have any questions. Good luck.